This is the video on chemical and physical properties and chemical and physical changes. So the chemical and physical properties of matter is what we are going to talk about first. And when we're determining if a property is chemical or physical, we can ask ourselves a question. And that question is, can this property be observed with no chemical change in the composition of the substance? So really, is the substance going to stay the same as we are observing this? If the answer to that is yes, that the composition will stay the same, that is a physical property. The answer is no, that is a chemical property. And so as we kind of look at these, we have two categories, and these are our physical properties of matter. These are often things that we can observe or collect information on in a lab setting. And again, they are properties that can be determined without chemically changing or destroying the substance. And there are two categories here. You don't need to know which ones are intensive or extensive, but it is important to know that intensive properties mean it doesn't depend on the quantity of matter. So it doesn't matter how much you have, the density of a substance stays the same. Same thing with color, temperature, state of matter. That would be like the state of matter on the next page. So is it in a solid state, a liquid state, or a gas state? And then also boiling and melting point are also both physical properties, because if you're looking at boiling point, you could go from liquid to gas, but we could just as easily cool that gas back off to get it back to a liquid state. And so you're not actually changing the chemical substance, you're just changing how those atoms are arranged and how much energy they have. And then melting point as well, same idea. Extensive physical properties, these depend on the quantity of matter, so it depends on how much you have. So things like shape, mass, and volume are also physical properties, but they will depend on how much of your substance you have. Chemical properties then are properties that are determined by chemically changing or destroying the substance. So the chemical properties that we'll see are reactivity. And since reactivity might be a new term to you, reactivity means how easily a substance reacts chemically with other substances. So if we were testing out reactivity, then we would need to actually combine it with something and then see how it reacts, which would impact what that thing is. Flammability is also a chemical property. We would have to set something on fire to see if it's flammable. Rusting, rotting or ripening of fruit, and pH. So how acidic or basic a substance is a chemical property. So if we want to determine if the observation describes a chemical or a physical property, referencing those things above, a shirt is red. So a shirt is red. That is describing the color. Color is a physical property. And feel free to pause this video if you want to try these on your own and then check. So tungsten, which is a metal, has a melting point of 6,192 degrees Fahrenheit. Melting point would be going from a solid to a liquid. And so that temperature is melting point is also a physical property. It's just changing the state. It's not changing the chemical makeup. Sorry if that got loud for a second. I was moving because people were talking. Kerosene is highly flammable. Flammability is a chemical property. Sandpaper is rough. Texture is a physical property. And the water is boiling. That's talking about that changing a state of matter, which is physical. And then we've got the pH of water, that is chemical. And that's because pH has to deal with losing and gaining hydrogen ions, which would change that chemical makeup. All you need to know right now, though, is that pH is a chemical property. All right, so from here, we can talk about chemical and physical changes. I'm actually going to stop this video here, and then I will come back with the chemical and physical changes part.